Same like Python, we have Ruby on Rails is also one example of interpreted language. And this Python interpreted language is very easy to write. Like there is less complexity in this code. We don't have like type restriction. We can declare any kind of variable. We don't need to declare the type of the variables as well, like C++ and Java, where we have to declare the what kind of data it holds. Right? Like for example, let's say if I declare an variable with integer a, right? Then I cannot assign any kind of different type of the data to this a, right? But in case of Python, I can declare. One time I can call it as for example, let's say if I say a equal to 10, which is my integer, right? But I can dynamically change the value a equal to strings. For example, so this is not possible in case of C++ and Java. Once you declare this value as an integer, we cannot change it by value dynamically. Okay, so other languages like compile language will report error for that while compilation, that its type is integer and that you are assigning the string value. So it is not possible in case of the compiled languages. So that is the beauty of Python language, that it can hold any kind of data. Okay, there are very like less complexity in the code. If you just see observe, it is also not using the curly brackets here. This all the code is based on the your indentation, which is like one tab space. For example, try block and this line having the one tab space. So in this way, this code is also like very properly managed, and also it is easy to write the code in Python. How pip install command works. So pip is a package manager for the Python. You can install Python packages with the help of pip. So the simple command is pip install and the package name. So for example, let's say I want to install a Django package. So we can do pip install space Django. So it will install the packages on your machine. So after installing this, so let's understand how this pip install command works. So pypy.org is the main source where the all packages are available. Okay, and whenever you type the command pip install the package name, pip will basically will try to connect with pypy.org. It will download this zip file or WAV file for that package, and it will try to download it. After downloading this file, zip file or WAV file, it will try to extract the file and it will try to execute this setup.py, and it will install the package on your Python interpreter. Okay, this is about how the pip works. The next question is, so how Python list slicing works. So as we list is a one kind of data structure in Python where the elements are arranged by the index. So we can create a slice of that list. So the formula for this list is basically, if you observe here in this answer, we have this sample list available, and the format, the first parameter for the sample list is the start index, second parameter is the end index, and the third parameter is the step counter. So start index means the index from where you want to start. The end index is the parameter where you want to end your slice. And the one thing we have to note it here is that the index element will not be part of your output list object. Okay, and the third parameter is the step counter. The step counter is the parameter which will be responsible for to increment the index. So the default value of this incremental counter will be the 1. Okay, so whenever you take any slice, all of your index will get incremented by the 1. Okay, this is about how the slicing works. We can take one example of this. For example, let's say I will open Python console, and let's say I will create a list object. Let's say I want to get the elements from 2nd to the 6th. So Python index will start from 0. So one bear will be at 0th location. Okay, we want to start from the first location, first index. There is first, second, third, fourth, and fifth. Okay, we want to get element up to 6. So L of first element to the, and we want the element at the 6. So 0, 1, 2, 3, 4, 5, and 6. So I will tell you why I'm taking this 6 as the last index element. If you observe here, so I've given this, I'm getting the all this slice object from the second to 6. So 6 is the index of the 7th element, but the end index is not the part of the list. That's why we have to give the one more extra index here. So let me just show you this formula again. So this end index element will be the never to be the part of your slice object. That's why we have to give that end element to make sure that the 6 will be the part of the slice. Okay, now the next question is, can we use Python list or tuple as a dictionary keys? So well, its answer is okay. Now our next question is, can we use Python list or tuple as a dictionary keys? Well, the answer is it depends on the how the dictionaries store their data. So in dictionary we store the key value pairs, okay, and the keys basically will get hashed to a function and it will generate one unique ID, and that ID will be used to store the value. It is same like your book. How exactly we have a book index, and based on that index we can find the corresponding chapter or page, right? So to save the values in your dictionaries, keys will be hashed with one function, and that hash code will be used to store the data. Now, if let's assume that we are going to use a list as a keys. So now we know that lists are the mutable, right? So if lists are the mutable, it can shrink, and it can decrease in size. So what happens? As the content is immutable, its hash will be also variable. So we cannot use a dictionary keys as a list. But whereas we can use tuples as the dictionary keys, because tuples are immutable. Once you create a tuple, we cannot change the content. So the hash code will remain same, and dictionaries won't have any problem to find out the corresponding key. That's why we can not use list as a dictionary keys, but we can use tuple as a dictionary keys. Okay, now the next question is, what are keyword and non-keyword arguments in Python? So well, Python function arguments are divided into two categories. One is a keyword and other is the non-keyword. The non-keyword arguments are the compulsory argument, okay, and the keyword arguments are the optional arguments. So I will show you just one example of how to define a function with a keyword and non-keyword arguments. So let's say a comma b and c equal to 10, d equal to 20. So in this function, let's say print a equal to and d equal to, and we can replace the all values by the format function. We can pass a comma b comma c comma d, and we can call this function from our main block. Okay, so the a and b arguments we call as a non-keyword arguments, and c and d are the keyword arguments. So all the compulsory arguments we call as the non-keyword, and all the default arguments, optional arguments we call as the keyword argument. Okay, so we can call the function. Let's say I want to pass a as a 1 and b as a 2, which are the compulsory arguments. If you don't provide this option argument, it doesn't matter. It will not report any error. It will accept the default values for the C and D. So if you don't pass this third and fourth argument, by default the C value will be 10 and D value will be 20. So let's call the function, execute the code. You see, A equal to 1, B equal to 2, C equal to 10, and D equal to 20. So A and B are the non-keyword arguments, and C and D are the keyword arguments. Okay. Now our next question is, can we create a function in Python which accept unlimited number of arguments? Yes, it is possible. We can create a function with unlimited number of arguments by using this arguments packing and unpacking. So we can use the same concept that we understand right now, which is the keyword and non-keyword arguments. With the help of this keyword and non-keyword arguments, we can create one function which accept the unlimited number of arguments. So let's try with this function. Okay, this is one function which accepts the n number of elements. Okay, for this sample function, I can pass 1 and 2. Okay, so if you observe, if I run this code again, okay, the arguments will be 1 and 2, which is will be by default all these compulsory arguments will be get merged into one ARGS, and all these optional arguments will become part of the keyword arguments. So if I send 1 and 2, that will be get packed into this ARGS. If I send keyword arguments, that will be get packed into the KWARGS. So let's add that as well. Let's say A equal to 10 and B equal to 20. So I'm passing these two keyword arguments. So right now this ARGS was the tuple 1, 2 because of this 1, 2 that we are passing here, and that will get packed into this ARGS. Now I'm passing this A as a 10 and B as 20. Now this will be get packed as a dictionary into the KWARGS. So we are going to it will print this dictionary with the A as a key and 10 as a value, B as a key and 20 as a value. Okay, if you observe here the output, the ARGS which having one tuple and KWARGS having the one dictionary content. And this way we can create one function with the unlimited arguments. So if I increase the count of the arguments, that doesn't matter. You see, now these are 3 arguments. These are the 3 key value pairs. Okay, so you can give as many as arguments that you want to this function. Okay, now next question is, can you reverse a list object by using a list slicing? Yes, so we can use the same technique. Now we understood that how to use this list slicing with the help of this step counter and start index and index, right? We know that concept, how exactly this list slicing works. So we can use the same technique to find out the reverse of a list. So let's take this example sample list. Okay, and let's say I wanted to print the reverse of this list object. So to find out the reverse of the list, is equal to, I can use a simple technique of slicing, which is the : -1. Now by default we know that start index will be 0, and if you don't provide any end index, it will go up to the end of the list object. Okay, but as we are giving the negative index here at the step counter, every time it will add this, first of all it will add this with 0 plus -1, it is a -1. So it will start from this last element, -1. Okay, so this 10th element, then -1 plus -1, which is the -2. will be the minus ninth element, 9 element. So in this way, it will go in the reverse order. If I run this code and if I print this reverse of this list, see, reverse object is the like this. So it has reversed the sample list from the 10 to first element. Now our next question is, can you remove duplicate elements from a list using Python built-in function? Okay, so sometimes we may face this problem, right? So we have a list of duplicate data, and we have to remove the duplicate elements from the list object. So same like this condition, we have a sample list object, and we wanted to remove the duplicate numbers from this one. So it is very easy. If you know about the set in Python, then it is very easy. Otherwise, we have to go with the normal for loop, and you have to find out this duplicate elements. So let's see how to remove duplicates by using the set and list. So I'm going to copy this input here. This is my sample list. I wanted to remove this all duplicate element from this list object. So unique elements. Set sample list. I will explain you what exactly happened in this statement. I'm going to print the output of this unique list. So this unique list is equal to 1. If you observe here, we don't have duplication. Now let's see how exactly it is working. So this sample list contains duplicate elements. We are passing this argument as a input to the set function. So set is a built-in function in Python, which will create a set data structure in Python. Okay, and by default, this with the set definition is the set is basically set of unique elements. It cannot contain duplicate items, right? So by default, Python will try to remove the all duplicates element from the set object. So we are as we passing this list object to set will remove the all duplicates element, right? And it will return the set as the output. Now this output we are giving again to this list function. List is also one built-in function which will create a list object from the given array of data. So again, we are going to convert this set object, which is returned by the set function, with the into a list object, and that list object will be get assigned to this unique list. And now here we are printing this unique list as the output. Okay, this is how exactly we can remove duplicate from a list object. It is very easy and very optimized way of finding out the or removing the duplicate elements. Now our next question is, find even numbers from the following list with the list comprehension. So as a data structure, using this list comprehension is very like helpful for us if we have like small requirements, or if you have like a small logic to implement with help of this for loop. We can directly go, instead of like implementing the for loop, we can directly go with the list comprehension. So in this, I've created one sample list as an input. This is my input list, and I wanted to find out the even numbers from this list object. So I will let me take the input from this question. Okay, and let's try to implement the list comprehension. So writing a list comprehension is very easy. It is same like your for loop, but there is some different approach to write the list comprehension. So list comprehension, or we can say we wanted to find out the even number, right? So even list is equal to. So first of all, declare one list kind of structure, square brackets. Then write a normal for example, let's say item in sample list. and then try to find out the even number formula. So we can apply if condition as well in this list comprehension. If my number mod 2 equal to 0. Okay, so if this mod operation is 0, means if a remainder is 0, then include this element into my output list. So you can say include in my output list. So let's understand this again. We are applying one for loop here. We are applying one if condition into this list comprehension. And if this condition is true, in that case only it will just add the element into output list. If this condition is false, it will not add this element into item list. Okay, so let's print the output. Now we got the even numbers here. So 2, 4, 6, 8, and 10. Okay, so if you observe here, in this way we can create the list comprehension. Only just normal for loop. If you want to use your condition, you can use the condition and just include the element as the output element. Our next question is, what are iterables in Python? So well, iterables are the Python objects which support the iter and next method. Okay, so any class we can create our own iterators as well, which implements the iter and next method that call as iterables. Iterables is anything that we can use in a for loop. For example, let's say a list object. List object is the iterable, and we can use in the for loop. Okay, our next question is whether list, dictionary, set, tuple, and strings are iterables or not. So all this data structure available in Python, like list, dictionary, set, tuple, and strings are iterable because they support the iter and next method. So let's demonstrate with the one list object. So as this is list object, if you observe here, we are applying this list object in the for loop. Why? Because list object support the iter and next method. So it has internally implemented the iter next method, and we can call this a list object here. Okay. For example, let's take example of one Python string. For example, let's say sample string is equal to HKR training. Now, if I apply a for loop, for example, character in sample string, print cat. If I run this code, yeah, if you observe here, we are applying a for loop on this string object, and what it does basically, it will we are applying a for loop on the string, and it will iterate over the one by one character, and it will print the output. So why it is possible? Because the string object by default support this iter and next method. Okay, so you demonstrate with that as well. So let's say for example, this is my list object. If I print sample string dot underscore iter, where we got the iterator object here. So for time being, let's say comment this code iter, and if I add one next method for this, it will give me the next value from the iteration. If you observe it, I'm getting only H here. Okay, Again, if I add the same print statement again, I will get a next value from the string object. H. Okay. So I will take this iterable object as the outside. For example, let's say iterator is equal to this, and I can use this iterator.next method to find out the one by one next character. Now I will get the HK. And again, if I type the next one more character, I can do with this HKR. Now I think you understood, right? We are getting this iterator here, and we are calling this next method on this iterator. So we are getting this next element from this string object one by one. So same thing happened with the list, dictionary, and all of the data structures available in the Python. Now our next question is, this was our question, whether list, dictionary, set, tuple, and strings are iterable or not. Explain. So I think we have seen one good example here for this list and strings. All the strings, list, dictionary support this iterable next method, and that's why we can use in the for loops. Now our next question is, can you find common elements in between the following list? So we have one list L1 and list L2. So let's try to find out the common elements. So if you want to find out these kinds of operations, sets are very efficient. So try to go with the set operation like intersection, union, join. So we can perform the different kinds of set operation in Python with the help of set data structure. Now I'm copying this input L1 and L2. Okay, and let's try to find out the common elements in between these two list object. So first of all, I will convert this L into a set object. For example, S1 is equal to, how to convert a list object into set? By using a set built-in function. I am passing a list object to this set. It will convert this list into a set object. Now again, this next set object will be the S2 is equal to set of L2. And now we can apply an intersection operation on these two sets. So intersection is equal to S1 dot intersection S2. And this output I can print on the console. If you see, we are getting this. Now these two sets only has a 4 as a common element, right? That's why the answer is the 4. So 4 will be your a new output set from this intersection operation. So it will what it does basically, it will try to find out this common elements from this S1 set and S2 set, and it will return a new set object which is the common elements into as output, and we are storing this information into our intersection parameter. Okay, this will we can call it as the intersection set, and that we're printing on the console. Now our next question is, what is object namespace in Python and how to find it? So namespace in Python is kind of collection of methods and attributes on that object, and we can find out this information with the help of the dir function. Okay, so let's see how to find out the namespace for any kind of object in Python. So it is very simple, it is very easy. For example, let's try to find out this L1 and S1. So what is the namespace of this L1 and what is the namespace of this set object? So first of all, I'm trying to find out the namespace for my list object. So list namespace, I will say L1 list namespace I will call dir function on this L1 object. If you see, for this L1, we are getting this namespace here. So namespace is basically collection of the all methods and attributes supported on this list object. So what is meaning of this? We can call all of these methods on this L object. For example, if you see, for general purpose, we have different methods available here for appending the operation, appending a list object, counting the elements from a list object, extending a new list object into your existing list object, finding out the index of the element from a list object, inserting an element into a list object, removing some element from a list object. So these are the all methods that we can use to on this list object. So this is the way how we can find out the which are the methods and attributes supported by this object by using this dir function. So we can apply the same function to the set as well. We can say S1 set namespace equal to dir of S1. So this will give me the another set of the namespace for set object. You see, this is the second list object, which is the namespace for my set S1. So this each object or each data structure has their own namespace. So if there is any custom class, you can also find out the corresponding method supported by this by the object as well with the help of this dir function. Okay, our next question is how to accept command line arguments in Python. Well, command line arguments are the parameters that we can give as input to your script. So sometimes whenever we write a Python script, normally we want to give the input to the script, right? And that on that input the script will work and it will provide the output. Okay. So for example, let's say this is my one hello world, right? Hello world.module, and I can pass this argument like this. This is one example how we can pass the argument. Whenever we run any kind of Python module, we run like Python and the that module name, right? Module name.py. After that, we can pass the arguments here, and these arguments we can access with the help of this sys module. So sys is a Python built-in module. So sys module has one argument vector parameter that we call as the sys.argv, and that this parameter we can be used to access the all the command line arguments. So let's take one example of this one as well. So I will remove this all of this thing right now. So first of all, I need to import this sys package here. So my command line arguments. args is equal to sys dot argument vector. Okay. So sys is my built-in module. On this module, we have one argument vector parameter, argument vector attribute, and with this we are going to call this. We are going to fetch this command line arguments here. So let's try to execute this Python main.py file from our command prompt. So I will type here Python main.py, and I will pass 10, 20, and 30. So we can pass these arguments like by using a space. There should be space in between this all of these arguments. Okay. We forgot to print this arguments here. Let's print that as well. Let's run this code again. Now, if you observe here, whenever we execute this code, Python, then module name and the arguments, command line arguments, we can able to access this command line arguments with the help of the sys.argv. So sys.argv will give me the list of the all command line arguments into a one list object that we are storing into this one variable command line arguments, and we are printing it here. The first argument will be the module name, and remaining all will be the arguments for this script. Okay, so in this way we can pass a command line arguments to any Python module. Our next question is, give the output for the following code snippet. Now let's understand this code, what exactly we are doing here. So first of all, giving any answer, first of all we need to understand this kinds of question. So in interview you may get some kind of this confusing question. So first of all, go through this question one by one and try to find out the logic given in that code. So in this code, it is very simple code, 4 to 5 lines of code. Let's understand what exactly it is doing. So this is my main block. Okay, in this I'm declaring one integer variable with a equal to 10, and I'm calling one function here, append to a list. So I think I'm not using it here, a list object here, but let's assume it is just one function. This function accepts one parameter argument a. Okay, and after calling the function again, we are printing the value. Okay, so let's right now its a value is 10. Okay, we are assigning to the 10 value. Again, we are passing this a to this function, and this in this function we are again assigning the a equal to 100. Right now, some people may feel that this a will be 10 value. Some people may feel that we are calling one function and again we are changing the value, its value will become 100. So like after the calling a function, this a value will change. Okay, but let's see. Let's run this code and let's understand what is the logic behind this. Okay, this is a function that we have get. Now, whenever we our execution will start from this line number 12. Okay, from main block, it will assign this a equal to 10. Okay, and now we are passing this a value to this function, and in this function we are again changing the value. Okay, but what happens whenever we pass this kinds of like numbers, all of they will get passed by the value, but not by the address. So meaning is that there are two concepts in the Python, which is the passing the arguments by the reference and passing the arguments by the value. So all the integer, string, all this immutable data structure will get passed by the by their value, but not by their reference. Okay, so this will not impact its after calling a function, the a value will not get impacted. Okay, because this a value will be basically the local to this function. Okay, so there will not be any impact for this on this call. Okay, so its answer will be 10. If I run this code, its answer will be 10, not the 100. Okay, I hope you understand this answer. How exactly we are getting this 10 as the output. Our next question is, give the output for this code snippet. So let's copy this code again and let's understand it one by one. Okay, so what we are doing in this function, we are declaring one list object with a sample list, and we are passing the sample list to the function. And what the sample list is doing, it is appending this some value to this list object. Now, whenever now this is one trick, right? So when we see this previous example, its value a value was not getting changed, right? Because its value will get passed by the value, okay, but not by the address. That's why there is not any impact on this a equal to 100 statement. So your value of a will remain as the 10, okay. But when you use a list object to pass the value, to pass this into as an argument, it will be get passed by the reference. Reference means by their address. And whenever you apply any append operation, it will impact the object as well. So because we are passing this object address here, right? So this, whenever we apply sample list dot append, it will update this content of this main list object from here only. Okay. So here we are applying this last element into 100, right? So my last element will be the 4, and if I multiply with the 4 with the 100, its answer will be 400. So the answer will be 1, 2, 3, 4 and comma 400. You see, 1, 2, 3, 4 and 400. These elements will be get added by this function. Okay. So even the why, because the list object will be get passed by the reference. It will be happen like same for the dictionary list, then set as well. Okay. So all of this will be get passed by the reference. Now let's go to the next question. Just we have completed now. Okay, now how to create a package in Python. Creating a package is very easy. Basically, package is just like your normal folder, but in package we add one more file, which is empty file that we call as underscore init dot. For example, let's say this is my one folder, interview workspace. I can create it as a package by adding the one more file in this, which is the create a new file underscore init.py. Okay. So in this way I can create this interview workspace will become a package. Okay. Now next question is, what is a PYC file and when it is created? So let's understand what is a PYC file. PYC file is basically a compiled code which is made by the Python interpreter. So it basically whenever you import any other different module, for that module Python will try to create the compile code. Why? Because whenever you run this file for the next time, so that it can use this compile code. Okay, so unless you update the file, it will not recreate the PYC file. So again, to avoid this translation of this source code during the execution, it tries to create the PYC code for the other files, so that it can be the time can be saved during the execution of the script. So let's understand how to create the PYC file, or how exactly that file will get created by Python interpreter. So this is my one module, main1.py. Let's create one more module. For example, let's say sample module 2.py. And let's write one function here, definition, simple function, addition of the two numbers, a comma b. Or I can pass any optional argument as well, c equal to 10, b equal to 20. Let's make a sum of this element. Return a plus b plus c plus 2. So we are just a simple function which will accept the 4 parameter, and it will return the sum as the output. Okay. Now let's execute this code. From sample module import add. You can just call add function here, pass 1 comma 2 comma 3 comma 4. Let's run this code. Say result is equal to okay. So this PYC code will be created here. Let me just I'm opening the corresponding folder to show you. Yeah. So in this interview workspace, if you observe here, we have imported this sample model 2, right, in the main.py file. So it has created this compile extension into this PyCache function. So this is a compile file .pyc file for this module. Okay. So in this way, Python will create the the PYC module for the imported modules. Let me open this code again. So what we are doing here, in this main.py, we are importing the function from this sample2 module. So right now I'm importing the whole function, whole module as the in this main.py, and from this module I'm going to call this add function. Okay. So Python knows that this module got imported from different module into this main module. So Python will create one PYC file so that whenever it will try to execute this main.py, so that it can directly import that PYC code. So it will not require again to compile the same sample model PY file again. So Python will do this optimization for the internal purpose to optimize the code or to improve the performance. Now our next question is, can you tell me different components defined in Python class? So in Python class, we have different components available. So let's understand it one by one. So first one is the class attributes. We can declare class attributes in a class. Okay. Then we have constructor. Basically, it is not required to write a constructor in every class. Based on the, if you want to initialize your object, we can write the constructor. The next one is the instance method. So if you want to perform any operation on your object, the data on the object, we can write an instance method. Instance method will have the access to the all kind of data into your object. It will have the access to the class attributes as well as the instance attribute. Okay. So the now the next thing is the instance attribute. So all the attributes which are saved into yourself, that we call as an instance attribute. I will give one example as well how exactly we can create all of these elements here. Then the class method. So the class method can be created with the decorator with @class method, and the CLS will be the first parameter for the class method. Then we will have the static method. We can create a static method in Python with the help of the decorator, static method decorator. Then we have class properties. We can create these getter and setter methods, and we have this also override method from the parent classes as well. So I think we cannot due to time limitation, we cannot cover the all parts, but we will try to create one class with one example of this class attributes and the constructor. Class sample. So we can declare like, let's say is equal to 10. This will be my class variable. Then I will declare one constructor here. Self dot b is equal to 20. And then I can declare our method to add the number. So let's say add return self dot a plus self dot b. So as I said, this self will have the access to these all class variables as well as the instance variable. Okay. The attributes which are declared outside this constructor that we call as the class variables, and the attributes which are declared inside this constructor that we call as instance attribute, and the parameter which having the first parameter the self that we call as the instance method. I will show you how to create the object of this class. Result is equal to, I'm calling the method add method on this sample object. So its result will be 30. You see, its addition is 30. So it has the access to the this object has access to this class variable as well as the instance variable with help of the self. Now let's go to the next question. When do we need to write a constructor in a class? As we have seen right now, if you observe here, this is one question which will like very important to understand the constructor, why we need to write a constructor. Normally, we don't need to write a constructor in any kind of class unless you need some initialize your object. For example, let's say in my object, I wanted to save this B attribute, right? So if this B attribute you need into somewhere in this other instance methods, then we will write one custom constructor. Okay. So whenever you want to initialize your object, we will need to write a custom constructor for your class. Let's move to the next question. Now, what is the difference between the instance method, class method, and static method? So I will show you an example. Now we have just seen example of this instance method here. Okay, the parameter for this instance method, self will be your first parameter by default. Okay, how to create? Let's see how to create the class method. You have to use a decorator here under the class method. Then let's say definition, sample class method. Print CLS dot. This is example of class method. Now if you observe here, this sample class method, the sample class method has this first parameter the self, sorry, CLS. This CLS parameter will be only have access to this class variable information. Okay, the CLS parameter, with the CLS parameter we cannot access this instance attribute B. We can have access to only this A parameter. That's why I'm written like CLS dot A. We cannot write it like here CLS dot B. Okay, this is example of class method. So the next question will be like why we need a class method, and so whenever we want to operate on this class attribute data, class attributes information, then we can declare a class method. Now let's see how to write a starting method. Just use a simple decorator, define your method. Let's say sample static method. This is static method. Okay, now let's see how to call this method. We can call this class method and static method by their class name only. So as of example of this add method, add is my instance method. We can call with the object, only with the object. But this class method and static method need not to create the object again. We can directly call with the by just class name. So let me just show you how to call this. You can call sample dot sample class method. I can call. No need to print it here because we are already printing that one statement into this method. So I'll directly call it. Okay, so this answer for this class method will be 10 because it will have the access to this class variable, which is a, and its value is 10. And the static method we are printing here like this is a static method. Now, the next question also will be like, what is different between these two methods? When we can go for the static method? So the answer is that whenever you want to implement things which are not required these class variable data as well as this instance variable data, then you can go with the static method. Okay, but if you need this class variable data, then implement a class method. If you need the access to the all this object data, then you can go for the instance method. Okay, so this is the difference between this instance method, class method, and static method. Now let's go to the next question. When do we need to write the class properties? Okay, so these class properties are basically a getter and setter methods. We will declare it as a direct property. So these properties are basically required whenever we want to process our object data and we want to return one output. For example, let's say in my class, I'm storing the different attributes like first name, last name, email, contact, residential address, and pin code. Okay, and every time I need to like print the like complete address to the user, right? Let's say I want to send an email to the user. So in that, if you want to like create one address of that user, a complete address, then again every time you have to write like object dot that attribute, right? So instead of writing like this all information one by one, what we can do, we can write a property like address property, and we can create this all information into the only the in only single format. So if you want to generate if you want to process this object data, and if you want to generate only one output, then you can go for the properties. Okay, let's move to the next question. Can we overload methods in classes? Okay, so normally Python doesn't allow the method overloading because we already support the optional argument, right? So that's why method overloading is not available in Python. But we can do the operator overloading, which is we can like add, subtract, multiply. So that kind of operator overloading we can do on the in the classes. And what will happen if you try to declare this two methods with same name? What will happen? It will try to call this latest method, which is available in your Python code. For example, let's say I'm writing one method here in this class. Let's say this add will be one, and again I'm adding and declaring one more method add. Okay, so if I just again copy and again try to like write the overload this method again. But second parameter, let's say this is first parameter. Again, I'm accepting the one more parameter. For example, let's say I want to change the let's say C parameter. Okay, and I want to again add this C into this one cell. So cell dot C is equal to C. So this parameter, so Python will consider this method as the final output for the consideration. It will not consider the first method because it's in the order of this method will be like this will be your last one, right? So this last method in your order will be considered for the as the final output. Okay, so whenever you call this add method, this method will never will get called. It will always call this second definition. So in this way, now we know that method overloading is not available in Python. So if you try to overload the method, it will just call this latest definition available into your Python code. Let's move to the next question. Okay, can you find out following code snippet? So let's find out the output of this code. Let's copy this code and let's understand the code one by one. Now let's understand this module. So here we are going to create one object of the sample class. Okay, in sample class we define our custom constructor, which will accept this a as one parameter. Okay, that parameter we are saving into one our instance attribute, which is self.a. Okay, a is my instance attribute here. Okay, and this method one is basically updating this self.a, right, which is a so if I create an object of this class, and if I call this method one, that object A method one will update its value from 10 to the 100. So whenever we are going to create the object of this class, by default it will call the constructor. Okay, what it will do, it will accept this 10 here, and 10 will be get added to your instance variable A. Okay, so cell.a will become your 10 value. Now after this, we are going to call this method one. When we call this method one, it will update this a value by the from 10 to 100. So whenever I say cell.a equal to 100, its value will get changed from the 10 to 100. And now if I print the value of the object.a, it will print the latest updated value, which is the 100. If I run this code, its value will be 100. You see the output of the a is the 100. Now in this way, now we understand it. What is the purpose of this constructor, and how exactly we can change the value over by calling them in the instance methods. Now let's see this next example here. Okay, let's copy this code. So all of this example has some logic or like some built-in concepts here. If you understand the concept, you could be able to easily answer the questions. Okay. So in this module, what we are doing, we have declared it two classes. One is the class one, okay, which having its own constructor, and class two, which having its own constructor. And the one interesting thing here is that the class two is inheriting the class one. Okay. Now let's see what we are doing in the main block. We are going to create the object of my child class, which is we are passing this a value as a 10. So what will happen? Whenever I create the object of this class, by default this constructor will get called, right? So this a value which is 10, that will be get assigned to this instance attribute, which is self.a equal to 10. Okay, that will get set here. And again in this constructor, we are going to call the superclass constructor. Okay, so this is the way how exactly we can call a superclass constructor. So we just have to use the super keyword underscore init underscore and just pass this argument for this constructor here. So we are passing this a here, and again what will happen? This cell.a will be get changed to the a into 30, a into 3. So if my cell.a value is 10 right now, after creating this object at up to line number 13, its value will be 10. But when I call the superclass constructor, what will happen? Its cell.a value will be get changed by the a into 3. So it will be get multiplied with the 3, and your answer will become 30. So object.a will be 30. You see, its answer is 30. So this question was somewhat tricky, but if you understand how that superclass constructor get called and how exactly it is happening in this code, then it will be very easy to answer the question. Now let's move to the next question. Let's copy this code. Like copying from the PPT, it's got its indentation is got distorted. So I'm just clearing that again. Now what we are doing in this module, we have created one sample class. We are having this class attributes equal to 100. We are having this constructor here, and in this constructor basically add this instance attribute A into yourself. Okay. Now whenever I'm creating this object of the sample class, we are passing this A as a 10. That will get added to your object here. Okay. And now whenever I call object dot A, we are referring to this instance attribute. Now here is the difference between these class attributes and the instance attributes. So here in this example, this is a one example which will demonstrate that difference between the class attributes and the instance attribute. So if you observe here I'm creating the object of the sample class, and whenever I call object dot A, this will access the instance attribute. Okay, from the object A, object one. So its answer will be 10. Okay, but whenever I call sample class dot A, now this will try to refer to the class attribute. Okay, it will not refer to the your object attribute because we are calling with the class name, right? So whenever I call any kind of attribute with the class name, meaning is that this should be a class attributes which is declared the outside the constructor, right? So its value will be 100. Some people may get confused that both value will be 10, but it is not like that. So this we are accessing the as a instance attribute, and here we are accessing the class attributes. So if I run this module, we'll get the answer 10 and 100. I hope you understand the difference of this accessing the instance attribute and the class attributes. Let's move to the next question. Okay, let's copy this code. I think it is image, so I couldn't copy that. So let's understand the code. I think we are able to, with this all the examples, we are able to understand the code. Let's understand the code here, and we'll try to print the output. Okay. So in this image, what we are doing, we are having this one class one, okay, which having this update instance attribute method, okay, and in this method we are going to add this one instance attribute here, which is the self dot equal to 100, right? And there is second class 2, which having the same method with the same name, right? Update instance attributes, which are also updating the adding one more attribute, instance attribute, which is self dot equal to 200. Now we are going to declare one child class which inherit the class 2 and class 1. Okay, and in this class 3 as well, we are going to create one custom constructor which are going to add this self dot equal to A. Okay, so while creating this, now in the main block, what we are doing, we are going to create the object of this child class 3. So I'm passing 10 here, right? 10 value as A. So this A will get assigned to this one, right? Object 1 A value will be 10. Now this object 1, if I call object 1 dot update instance attribute, so with the rule of the inheritance, we know that whenever we inherit classes, like this class 3 is inheriting the class 2 and class 1, okay, so all the methods available in your parent classes will become the part of the child class, right? That we know by the property of inheritance. If you inherit any classes, basically all the attributes and methods will become the part of your child class. So by default, all of this method will be available here, right? But here one problem with this is that now there are these same methods available into this class 1 and class 2, right? So it is very difficult to find out which method will get called. For that, Python uses a method order resolution. So basically, the order in which you are declaring your inheritance order. Basically, first of all, we are inheriting the class 2, and then we are having the class 1, right? So by default, this class 2 method will get called. The meaning is that this class 2 method will get called, and the self a value will be 200. So its answer will be 200. That's why its answer is a will become 200. Okay. So here is the concept of the method order resolution. By the order in which you are extending or extending your classes, corresponding method will get called. For example, let's say if its order is class 1 and class 2, first of all class 1 and then class 2, then it will call the class 1 method. Okay, so whichever is the first available from that method, it will call that corresponding method available. Okay, let's move to the next question. Okay, now let's copy this. I think we have just seen that. Yeah, we have completed this one. Now this next question is how to call a shell commands from the Python. Okay, so we can call shell commands, okay, with the help of the Python as well. So for example, in Ubuntu we have like commands like make dir, rmdir to remove dir, right? So these kinds of commands we can also call from the Python as well. Okay, for this Python has provided this subprocess module, so we can use this subprocess module to execute the shell commands. A simple statement is like from some subprocess import this popen method, and in this popen method you can pass this list of the arguments here, okay, which is your command here basically. So mkdir, so basically this mkdir command will make the one folder at the home/core Python. Okay, so it will basically create the folder here, folder for Python. So this command we can execute with the help of this popen. Okay, this popen will be the part of the subprocess. So subprocess is the built-in module in Python, which will be useful to create a new process or to execute the shell commands from the Python. Now, okay. Now our next question is that what is the base class of the all errors in Python? Okay. So first of all, what is error in Python? So whenever we execute any kind of code, what happens? There is abrupt termination of your code, and your Python code will stop to execute after that line. For example, let me demonstrate that. For example, or we'll just keep this example as it is. But let's say before like this statement, I'm going to print this 1/0. Okay, so this answer will be its answer. Python cannot handle this kinds of operation, mathematical operation. Right? Its answer will be infinity, and it cannot handle this. So what will happen at this line number 16? It will generate an exception here, which is like division 0 error, right? And it will not able to execute this line. It will print this line, but it will not execute this line. That's why this output will not get printed here. So if I run this code, it will be able to print 10, but it will not able to print 100. Let's see. You see, it has printed the a:10, but it has not printed this next value a100. Why? Because this line number 16 has raised this error here. So with this 1/0 error, what is happening here? It will execute. It will throw the 0 division error, and that will be it will terminate your code here. So in this way, our base class of this all exception is the exception class. So whenever it will execute this, it will raise this 0 division error. So this 0 division error basically is one kind of exception, okay, which is of type exception class. Basically, all exceptions, like for example your 0 division error, then key error, value error. So all of these are exception in Python, and they are the child class of the exception class. So all of them are the child of exception. If you observe here, this is the base class for the all exceptions here. Okay, all of this error in Python, whether it will be like built-in or it will be custom, they are the child of this. They have the parent as the exception class. Now let's move to the next question. Name a few built-in exception in Python. How does Python invoke built-in exceptions? So as of now, we have seen like these examples here, key error. So key error will be basically created whenever we try to access a key which is not available in your dictionary, right? So for example, I'm going to let's raise the key error here. It's I'm declaring my dictionary here, which having okay, and let's try to access the key which is not available here. So this will raise a key error that key C is not available here. So this is how the Python has raised this key error example. Okay. So Python basically will create the object of this key error and it will throw to your program, and this program will basically will show this error on your screen. This will happen like same with the all kinds of exception. What is happening at line number 16? It is creating this zero division error, and Python will throw this error to your program, and program will stop the executing the program, and then it will show this error on your screen. Okay. Value error will be basically created whenever you are trying to add the strings and integer, right? So strings and integer you cannot add this to value, right? So this will raise this value error. Name error will be get raised whenever, for example, let's say if name is not available and then you are printing the value. For example, let's say S. This is a name error. So for Python doesn't know about this, what exactly is, right? So that's why it is raising this name error for this S. If I declare S equal to 10, then it don't have any issue. It can print the S value as 10. But if S is not defined there, if you're trying to access the value, then it will become a name error. Then index error. So whenever you're trying to access this index element by their index, and if the index is not available, then it will raise the index error. For example, let's say I'm creating one list object 1, 2, 3. Let's say this I'm giving an index which is like for the value is not available. For example, L of 9. Now this L of 9 is not available, right? So it will report the index error here. Because this 9th index is not available into this list object, that's why it is reported this index error. Now let's move to the next, our last question here. How do we handle exception in Python? So as we have seen, right, how the Python is raising this exception, and now we know that all these exception are like base class has an exception class, and they will be get raised by the Python code. Okay. So now how to avoid this kinds of exception here, and how to make your code run even though if your exception got raised. So for that, Python has this try except block mechanism. You can implement a try and except block. Let me show you how to handle this exception here in this our code. What I will do, let's say right now in this line number 16, we are getting the exception, right? What I will do, I will write the try except block here. Or right now I know that, right? This error will be get created at line number 3. What I will do, I will implement this try and except block here. Okay. Now if you observe here, I put my the exception code which is in the try block. Okay, so the Python will raise the exception that will be get catched by this except block, and this error will get handled here, right? If I execute this code, it will print the A as a 10 as well as the A as 100. It will not block your code, right? In this way, we are able to handle the exception, and your program will not raise an error, and your script will get executed smoothly. Okay, so in this way we can handle our exception with the help of the try and except block. We also have one more block here like finally as well. Okay, so this block will basically used to execute the statement. If you want to execute this statement at any cost, for example, closing this database connection or closing the file handler. In that case, this kinds of finally statement is useful. For example, this is finally block. If I run this code, this final block will always get executed, whether my error will be get raised or not. For example, let's say if the error, I'm not raising the error right now, still it will be able to execute this line. Okay, I'm not raising the error right now, but still I'm executing this final block. Okay, so in this way we can handle the exception, and we can log this kinds of error into some logger and for your application. Okay, so this is all about the different questions that we have taken from the different topics. We have seen the list, data structures, and functions, classes. Oops, constructor here also we have seen with the code with this interview questions. Also, we have covered the exception handling as well. Okay. So thank you all for watching this video.
Mr. Vikas, first question is left.
Yeah, sorry. Yeah, so we have this first question. Now, what is a Python? So Python is basically an interpreted language. Okay, so meaning is that if you observe here I'm opening the interpreter here. This Python is basically this is the interpreter console. We can execute this kind of code is getting executed line by line. Okay, it is not like everything will get compiled initially and then it will be like executed. For example, C++ and Java, these are the compiled languages. What is the meaning of compiled language basically? So before executing this code, every time they will create this compile code. Okay, then after that that will be code executed. But in this case, for example, in case of main.py, this code is getting directly executed. Python doesn't create the PYC file for this main file, though it create the PYC file for the other imported module, but it is not going to create the PYC file for this main module. Okay, it will directly execute the code line by line. That's why we call it this interpreted language.